Hello, everybody. Let's talk some cardioids and limacons. So most of this day, you will actually do most of the work on your own. I made this video just more so for giving the instructions, and then we'll go through the final what you need to get out of this next class. So we are on the page that says Cardioids and Limacons without loops at the top, which is basically our next page in our notes. And what you're going to start off doing is filling out this table. Now, this table is to help us graph by hand, which we won't do very often. I do like to start off with it just as we always start off graphing. You always start with like a table, and usually you would do X and Y when you're in a rectangular grid, but instead here we're actually going to do theta and R. Now, you'll notice we switched it. You know how normally X comma Y and our points are actually R comma theta. Well, in general, you could choose either thetas or r's to substitute in, but in general, it's easier to choose thetas to substitute in because we've solved for r. So really, it's just you choose a theta, you simplify what you have on that one side, and you'll get your r value, just like how normally we like to solve for y in x's and y's. So then we choose x values to substitute in. Same idea here. So what you're going to do, you're going to go ahead, and we've already chosen thetas for you. You'll see we chose really nice ones. So we chose 0, pi fourths, pi halves, 3 pi fourths, pi, 5 pi fourths, 3 pi halves, 7 pi fourths, and 2 pi. And maybe you'll realize, we went from 0 to 2 pi, because once we go past that, we start just getting the same answers over and over again because of that coterminal or that periodic nature of cosines and sines, right? All right, so what you're going to do is you're going to go ahead. That middle column is just kind of helping you out figuring out what your cosine is. And then you're going to then just find out what your r is. Now, you'll see in the directions, I want the exact value, and then I also want the decimal approximation, because the decimal approximation will help us graph this much, much easier, and you'll graph them by hand at the bottom. So first thing, we're going to go ahead and do cosine of 0 here. Now, I'm more so showing these steps so you guys can see them. Cosine of 0 is 1. Okay, so then I'm going to go ahead and say, I'm going to do 3 plus 3 times 1. Simplify that, and I get 6. So my first coordinate point is my angle of 0 and my r of 6. So you can do it in either order if you want. I'll just go down here just to kind of show you. So 0 goes 0 degrees or 0 radians, and I go out 6 circles. 1, 2, 3, 4, 5, 6. And there's my first point. Okay. And then I'm going to keep doing that throughout. I'll do one more for you guys, and then I'll have you guys work through this, and I'll also give you guys some directions for the next part. So pi fourths. So cosine of pi fourths. Well, if you don't know it yet, you can draw your triangle if needed, but cosine of pi fourths is root 2 over 2. So you go ahead and you put in root 2 over 2. Now, for the exact answer, when I multiply it, I get 3 plus 3 root 2 over 2, and that's my exact answer. Now I'm going to go to my calculator and just type it in just to see what the decimal equivalent is. 5.12, because I did say the hundredths. So 5.12. So now I'm going to go to pi fourths, and I'm going to go 5.12. Pi fourths is this middle line, so I go out just over 5 circles. So 1, 2, 3, 4, 5. and I put a little point there. And then, like I said, I'm going to have you guys finish this off. So go ahead, take your time, figure out all of these points. You will see a lot of points starting to repeat themselves. Okay, you'll see a lot of symmetry through this. So we'll go ahead and finish this off. So pause this video, and then I won't actually have this done for you, but I will show you how to, once you have all your points, I'll show you what it looks like in the calculator, so that way you know how to connect it. Okay, so like I said, take a second, pause the video, and then come back. Okay, hopefully you did pause it, and now I'm going to show you how to put these into your calculator, so that way you'll know how to connect our points. So I'm going to pull up my calculator program here. Now, I will tell you, you do want to use the TI-84 or 83, whichever one you have. If you don't have the actual handheld calculator, your Chromebooks have this the TI program installed. So if you actually go to your bottom left and actually search and you type in TI, you should see the TI program in there. You'll be able to do it on the computer if you don't have your handheld calculator. The TI program's much better in terms of graphing polars for what we want to do, as opposed to Desmos. Desmos can do it, but it's not the greatest. All right, so what you're going to do to put this in your to graph this in your calculator, you have to click on mode first, and there's two things we're checking. First, we should be in radian mode. If you used your calculator at all to help you with the table, you were hopefully already in radian mode. And then the other thing, if you look at your calculator right now, it's probably got function highlighted in black, or however it's highlighted. Okay, that right there is your y equals. So what you want to actually do, though, is you want to go over to polar. Now, depending on your calculator, it might just say POL instead of polar. It's the same thing. Okay, and then what you're going to do is you're going to hit y equals, just like we would graph anything else, and you'll notice something different. You'll notice it's R1, R2, R3, so on and so forth, instead of Ys. So here we've changed our calculator to radian mode. To polar mode. If you want to change it back, you put it back onto function. Okay. But here it is. So now we can start typing. So 3 plus 3 cosine. And then you'll notice theta. Well, the button that we use normally for x, this one right next to the alpha button, if you read it carefully, it says x comma t comma theta comma n. So depending on what mode your calculator is in, that actually changes what this button does. So if I hit that button, it puts in theta for me. Okay. Now, if you hit graph, depending on what your window is, you'll see our graph here. You might, what's the best? I like to do zoom 6 and then zoom. I do 2 zooms. So zoom 6 to fix my window nicely, and then zoom square to make it look really nice. So it's not as like oblong. So this first graph, and this is kind of how you would connect your points in this shape. This is a cardioid. Okay. And if I was in class right now, I would ask you guys, why do you think it's called a cardioid? And hopefully one of you can already see it. It kind of looks like a heart. Okay, it has that heart aspect to it. And you'll see more examples on the next couple pages, but it looks like a heart. Okay, and then if I want to just check out the next one, 3 plus 2 sine of theta. So there you go, 3 plus 2 sine of theta. So this would be your second table. So this is for the second graph here. You hit graph, and you'll notice this one, it does not go to the origin, right? It kind of flattens out here. These ones kind of look like kidney beans or lima beans. I like lima beans because it's a limacone. So yeah, that's kind of their shape. Okay, so that right there is how you graph them. So y equals 3 plus 2 sine of theta. And honestly, once you have your window set like this, you really don't need to change it much for the next part. So you don't have to hit the zoom button really anymore. If something gets larger, you might have to like do the 2 zooms, but for the most part, this window is perfectly fine. So you really just have to do the y equals, put the equation in, and then hit graph, and you should be fine. All right. So speaking of what I want you to do next, what I want you guys to do, and you could do this, hopefully if you have your calculator, or like I said, use the one on your Chromebook. What you're going to do is you're going to actually graph all of these graphs, okay? So there's 4 on the first page, and I'll tell you the first 4 are all cardioids. So these are all cardioids, okay? And then the next page is 4 more graphs, and they're all limacones. Limacones. Okay, and they're actually all limacones without loops, which we'll talk about ones with loops next time. But I want you to be able to graph all of these, okay? And I want you just to tell me things you notice and things you wonder about them for about each graph, okay? And you'll notice in the directions I even kind of give you a little hint on in terms of what to look at. Look at how it hits the x and y axis. Now, technically, there aren't x's and y's in polar, but there are still x's and y's on these graphs, so you can kind of look at their x-intercepts and their y-intercepts, okay? And that's something I want you to focus on. But then, 2, just anything else that you kind of notice, any patterns you notice with these graphs. So like I said, the first 4 are one group. The next 4 are another. And then once you have all those done, if you wanted to discuss with someone else just to kind of see what they think, that's totally fine. But then there's this summary here. Now, if you want to try to fill this out, you can. Otherwise, we can fill this out together next time that I'm in class, hopefully. There is a couple changes, though, I do want you to make. Instead of saying x-intercepts and y-intercepts, we're actually going to put key points, because I think it actually gets confusing where we throw in x and y-intercepts, because we're talking polar graphs, but x and y-intercepts are specifically rectangular coordinates. So I personally, I don't like it that it says that, so I changed them to key points, okay? And they're the points that represent the x and y intercepts, but we're going to write them in polar form as opposed to rectangular, okay? But yeah, you can see it matches up with the 4 graphs you did, and then the last 4 graphs you do with the limacones, okay? So if you want to fill this out, you can, and you can fill out as much as you want. I think, honestly, the last 2 rows you should be able to fill out after seeing all 4 graphs. It's truly not too bad in both cases. I will say you can use terms like x-axis and y-axis, okay? It's the easiest way of describing them. It's what we're most comfortable with. But yeah, go ahead. Like I said, work through these 8 graphs. See what you notice, see what you wonder. Try to fill this out as best as you can. And then, like I said, next class, we'll actually go through this so that way you guys can have it filled out, hopefully, correctly. Okay? So, yeah, thanks for watching, and have a good day.